students, welcome to Veteach. Yeah, today we are going to discuss about queues implementation using linked list. Yeah, we have learned queues implementation using arrays, isn't it? Yes, now it's time to learn about queues implementation using linked list. You may get it out. Why too many implementations? We already implemented queue using arrays. Then why we go for linked list? Yes, while discussing in the stacks, as we also discussed one thing. What is the drawback using arrays? We all know array is a fixed size of memory. So if you give the size as 5, it means that you can store only 5 elements maximum, isn't it? Okay, if you want to store, if you give the size 50, it means that you can give any 50 elements, isn't it? Now I want to give one more element. We can't insert one more element in this array. Why? Because the maximum size is 50. Yes. So here you can see here the array implementation is used for only fixed memory allocation. Okay. Whenever you go for you want to implement the queues, but you don't know the size. Okay, you don't know the size of the array. You want to insert elements, how many you want as your wish. Then what we need to do? We go for linked list representation. And not only at that such cases, linked list representation is used for when you want to insert unlimited elements. At such type of cases also used for using this linked list representation. Okay, let us see how we represent the queues using linked list. Okay, so we all know what we know. We all know the node. What is the node? A node contains two fields, isn't it? One is a data field, the other one is link field. We also represent link as a next also. Okay, so here the node, here in this node we insert the elements. In which field we insert the elements? In data field we insert the elements. Let the data be n 9. Okay, so you want to insert one more element. For example, there are elements like 9, 5, 4 and 3. Okay, according to queues, what we do? Yes, according to queues, how these elements will be inserted? So the elements will be inserted in this form, isn't it? 9, 5, 4 and 3. Okay, so the first element will be in the first location. The next will be 5, 4 and 3. Or you can see like this: 9, 5, 4 and 3, isn't it? So these are the two ends. So as we know in queues, what are the two terms will be represented with which the first element will be represented with friend, the last element, the latest element will be represented with rare, isn't it? Yes, according to the queues implementation, the elements will be in this form. Okay, first element will be in the first location. Yes. Now according to linked list, what we need to do? We have to create a memory for each and every element, isn't it? I mean, one node. For 5, I have created one more node. For 4, I have created one more node. And for 3, I have created one more node. Okay, so for each and every elements we have to create a separate nodes. Okay, fine. Now what we need to do? We should follow the queue principle. What is the queue principle, guys? The queue principle is first in, first out. So what is the first element here? 9. So the order should be also, the first element should be 9, later 5, later 4, later 3. Okay, fine. Now what we need to do? When we also know, when we create a node, what happens? It allocates some memory location, isn't it? So for the node 9, just let us assume the memory location as 500. For node 5, let the memory location as 550. For 4, node 4, let the memory location be 400. For 3, 300. Okay. See, the memory allocations will not be in order. So why? Because as it is a dynamic memory allocation, we all know while creating the memory, what we call, what the function will be used here? We use the mloc function. So what the mloc function will do? It creates the memory dynamically, randomly. So that is the reason behind each and every node are created at random memory allocations, not in the sequence memory allocations. Okay, now what we need to do according to representation, what is the node after 9? 5. So in order to in order to follow the queue principle, what we have to do, we should write the address. We should take the address of node 5 and we should fill in the link. So what is the node 5 address? 550. Whenever the link address, the link is having the 550, what it means that here the link will be created for the 550 location. And similarly, whenever here in the 4 there is a 400 address in the link for the node 5, it means that it points to the 400 location. Similarly, 3, it means that 300. So it points to the 300 location, isn't it? Now you can see here, this is the last element. So it should be represented, the link should be represented with null. Okay, here who is friend and who is rare? Obviously, we all know the first element is 9. So the friend should be the first element 9. And the last element is rare, 3. So it should be pointed with rare. So this is what the representation. Okay, now let us see by using the logic, how we use the logic here for insert operation. Okay, here you can see what we do is, first of all, we create two empty nodes. Okay, friend and rare with null value. So there will be no elements. Friend and rare are null. Okay, so in order to insert the elements, what we do, guys, we should check whether it is friend is null or not. Before checking the condition, what we have to do, first of all, we should create the pointer for, first of all, we have to create a node. Here in this algorithm, the name of the node is pointer. Okay, so here what I am doing is, just I am creating the node with the name of PTR. Okay, let the memory location be 200. Now, what is the value we are assigning? Item. Item is nothing but the elements. Okay, so the elements whatever it may be. So in which field we are going to insert? Data field. So PTR points to data. Okay, here item. Here for example, item is 543, for example. First element is 5. So here 5 is going to be inserted. Okay, now it is fine. Now pointer has been created with a node with the location of 200 and the element is 5. Here nothing has been updated, just they have placed empty. Now they are checking the condition whether the friend is null or not. Yes, friend is null. Then what we need to do? We need to assign the pointer, whatever the pointer, to the friend, and same as the pointer which should be points to the rare, and the next part should be null. See, what is the pointer means? Pointer means the address location. Okay, so here what happens? We are going to assign friend equal to 200. It means that friend is pointing to the 200 location. So finally what will happen? The friend will points to the 200 location, the which is where the same, what is that pointer is pointing to. Here the element 5 has been updated. And similarly, rare equal to PTR. What is the PTR value? 200. So it means that rare is also pointing to the 200 location. Okay, next what are the two step, guys? We should update the friend next null and rare next null. Friend next means this is the part. As I said, this field can be called as next or also called as link. So what I am trying to assign? I am trying to assign null. Friend and rare are both are same, so just we updated with null. So this is the condition for when this condition applies. This is the condition when we insert the very first element. If the queue is empty, how we need to, what is the condition to check the queue? The condition is we have to take the condition whether the friend is equals to null or not. Okay, fine. Now what we need to do? We need to check whether if the queue is not empty. It means that some elements are there. We don't know whether how many elements are there. Some elements are there. It might be one or it might be more than one. Okay. So here you can see I am going to create one more element. I am going to insert and queue the element 4. So what we need to do first of all we need to check whether first of all, we need to create a pointer. So, pointer has been created. Let the memory location be 250 and in the pointer data part, the 4 has been updated. Now, I am going to check whether friend equal to null. Is friend equal to null? No. What is the value in the friend, guys? The value in the friend is 200. So, what we need to do? We need to go for second case. What is that second case? Once you see here, they are saying that update the rear next equal to PTR. So, what is the PTR value, guys, here? So, what is the memory location? The memory location of PTR is 250. Now what we need to do? We need to update this 250 in the rear next pointer. So where the rear next? This is the rear next. So what we need to do? We should update this 250. It means that it points to the 250 location. Just I am placing this node beside this element 5 just for representation purpose. Okay. So 4. So what's the next point here? Then mark the rear equal to PTR. So what is the PTR value, guys? 250. It means that first of all we should update the rear next part. Later we should move the rear to that part. So here the rear will be pointed to the 250. Okay, whenever here 250 is updated, it means that a link should be created for the 250 location. Then later you should update the rear next part equals to null. So here we update this one. See guys, here according to queue principle, the last element is pointed with rear. Yes. The first element is pointed with friend. Yes. So this is the condition. So in order to, whenever we are going to insert an element, so the very new element should be always pointed by the rear. In order to get pointed with rear, we should go for this second case whenever the new queue is not empty. Okay. This is what about algorithm for NQ and DQ. Thank you.